Okay, let's go ahead and get started. Take a seat. Okay, we got a lot to go over. Do you want our help to work on this together or not?
Yes.
Because if you don't want my help, that's fine. If I was going to place wagers on this, okay, some of you, you're not going to do very well tomorrow. That's the choices that you're making in here.
Is that just an assumption?
Presumption. That's what I said. All right? So therefore, do you want our help or not?
Yes.
Because otherwise, again, if I could make a presumption, some of you, when you're working on these papers, you're doing it together, which is fine. But then when you're responsible for this material on a day like tomorrow, you don't know what's going on. So why is that?
Maybe you're not paying attention.
That's quite possible.
Maybe you're just lazy. Maybe you have short-term memory loss. Maybe you need to get your feet off the table. Yeah. Maybe your name is Chris.
Okay? And we're not going to sit there. Up here.
You're just mad because he's in Anna's spot, son.
Okay. We've gone over 2 types of reactions so far. We'll go over these before the end of the hour. Okay. On tomorrow's paper, you do not have to classify anything. You are just balancing. Possibly. Okay? This content continually builds upon one another. What you learned last chapter is another aspect on what we're going to do this chapter. Okay. So, what type of reactions have we talked about so far? What types? Combustion is one. Okay. In composition or combustion's the other. Okay. What would be the simplest way to explain a synthesis reaction?
It has one on the other one side. It's a hydrogen or it's a carbon dioxide hydrogen. Did they give up
No.
water?
Oh my
No.
God.
Simplest type.
The simplest way to explain a synthesis reaction.
Hydrogen plus oxygen.
And you're making something. You're making water. That is the simplest way to explain this. You are making something. You're taking 2 substances and making something more complex. Okay, so if we had to guess, make a presumption, what would the opposite of synthesis be? No.
SYN.
What happens to mercuric 2 oxide?
They decompose.
Yeah, it breaks apart. So the opposite of synthesis is decomposition. Okay? So that's when one or more substance or substances breaks down into simpler substances or elements. Sorry, I didn't mean to kick your lunch bag there. So if they require heat, light, or electricity, those speed up those reactions. And what is that called when something gets sped up? It's a specific what? Starts with a C. One of your vocab terms too. Not an inhibitor, but rather a catalyst.
Oh yeah.
Okay?
Catalyst.
That's what we just said, yes. Okay? Does everyone have this content that wants it?
What might that be?
Because I don't need it. I'm a visual learner.
Maybe you're like.
Okay? All right. That's your choice. This just helps me explain this content to you. Whether you choose to write it down or not, that's up to you.
Are we gonna fill out this whole packet?
Mm-hmm.
Stop. Everyone's got it now.
Okay. These are probably some of the toughest ones, the single displacement or single replacement, along with double replacement. Okay. We'll explain that in just a moment. So, the best way to explain a single replacement reaction, what would you possibly be looking for in the reaction? Just a what? A single element, okay? If you have an element that is all by itself and you have a compound it's reacting with, that is a single replacement. So what happens with this, okay, many reactions can be predicted, okay, by what we call the activity series, okay? When you look at the table, as you go down in column 1, those elements become more active. That's why we refer to that as the activity series.
Let's do this. Everything good?
I counted 20,
How many are in here?
Anna's gone.
okay,
And
Jacob doesn't have a phone.
okay,
Jacob doesn't have his phone, so that'd be 23.
but there's more than 23 in here. There's 26.
Uh-oh.
Mhm. So would it be a presumption that everyone's got their phone up there?
Yes.
Yes.
I've got a tablet. Maybe not.
Chris doesn't have his phone too, so take away that.
Okay? I'm standing back in my favorite part of the classroom.
Right next to me.
Yeah, right next to James.
So
Is that a good
my
one?
question is, how simple is it to just come in here and just do what's asked of
Everyone
you?
has their phone. Pretty easy, but
Okay.
maybe some people might
Good.
think it's
Then I won't see anybody out on that, then will I?
probably not.
Okay?
Do you have something bad? Yes, little thing. I can't see something.
So why would he make a comment like that?
Give you cellular Because I heard it make a funny noise.
Oh. Well, do you have your mobile device on you?
No.
Is that true?
I don't think he does.
Okay. Again, when we're taking time away from class from, is this a good presumption? This side over. They see the reason that they want to learn this. And it's not everyone from over here. And when we got to stop and do this, we say that's pretty selfish, isn't it?
What did we do?
I didn't say that anything, did I? I said, what I said was, I think it's a fairly good presumption. Why do we got to stop and have all these sidebar conversations with everyone over on this side over? Probably sees the reason that they want to learn this material.
In my defense, my phone got taken away today, so okay. I don't have
Okay? So again, doesn't that take time away from everybody else?
no.
Right?
Uh-uh.
It doesn't. So everyone will be on the same page. They can do everything that's going to be behind that whiteboard or that screen.
They can write it down while we're talking.
I'm gonna move to that side of the
Okay? Something to add?
I don't have much to add.
Oh, okay. 1, 2. We got 2 left to go.
Oh, shoot.
Because what we do then is what you have been writing down, we apply to what's behind that screen. It just makes it easier for you to learn that and apply it. Okay? Just to be honest, I think as a group you're pretty smart. I do. My honest opinion. I really think this group is pretty smart. But do you use that intelligence? Oh, just when you feel like it. Okay. Well, something said to be honest. In a matter of speaking, that's what I just said. We're not concerned about what's going on outside this room. It's none of your business.
We're trying to learn. There could be a fire.
Okay. Let's change just a little bit. I got a paper for you here in just a matter of moments. It's due on Thursday. And on Thursday you get another one.
It's on Friday. No. The 22nd. 3/18 is Friday.
Yeah. The one on Thursday.
It says it's due on Friday.
It does say 3/18, don't it? Okay. So 3/17. Okay. I got to change that. So I will make that change right now. Okay. So 3/18. I keep thinking that St. Patrick's Day is on Wednesday, on Thursday. All right. Does everyone have this content that wants it?
Yeah, no one's right. Actually, I already have this one.
Okay, the last one. Sometimes this can be the most difficult when we do an activity next week. This is what you're producing. Okay, so what's a way of explaining rain, snow, sleet, hail? Those are all forms of precipitation, which means what? True, falls out of the clouds. My main point is it's falling out of the clouds. This falls out of the solution, okay? So when it falls out of the solution, it's known as a precipitate, okay? So that's what you do. You take two substances, react them with one another, okay? And then you calculate how much precipitate you actually formed as opposed to what you should form on pencil and paper. Okay? It's these types of predictions that chemists would probably utilize to see what is the most efficient way to make different types of substances.
How was the SHU anatomy center?
Sorry, what?
How was the SHU anatomy place or whatever?
What about the anatomy lab?
Was it good?
Ask the students. Yeah. Juniors and seniors. Yep.
We're done with this time, my boy.
Okay. Is it safe to say we can shut this off? What are we doing? Why are you squirming around all?
I'm having an aneurysm.
What's so funny about that?
Maybe he's serious.
Oh, but you told me you don't have your phone.
Yeah, at least
Okay. Can I take your word for it? Would you not tell the truth to me?
I would never listen to him if I were
I won't listen to me.
So if that's the case, everyone else can do this but you. Why is that? You don't have an answer for it, do you? So it would be a presumption that your phone is on you. You say you got it taken away. What's so funny about that, having your phone taken away? So, again, everyone else can do this but you.
There are some people over there that
Okay, so with everything that we've learned, you should be able to complete that. Okay, good. So you won't mind doing it then. Everyone, write this down.
All right.
No, there is no choice on this one. We're writing this one down.
You don't have a choice on this.
Where do you write it down? So that's a single replacement. Good to know.
SB, that's my initials.
Where do you see SB?
Yeah, them are SRs, buddy.
Oh, I must be blind as a bat. I think you are. That top one looks like a B.
I'm just wondering, what are you doing?
I repaired my cancer.
Got it written down, boys.
Hey, I can't see that blue one. I can see glare. It starts with a C. Oh, yeah.
Hydrogen sulfate plus cobalt 3.
My notebook out right.
That means it's got a +3 charge.
Really did.
Oh, I didn't know that.
So I'm so glad that you're doing this so that when tomorrow rolls around, it's going to be really simple. No, you cannot use that. You can use your table. Mm-hmm.
Write it on the table.
So right on the table.
Well, then, if that's the game we're going to play, we'll just put the periodic table up on the screen, and no one gets a periodic table.
We're not playing that.
I think that's what you're doing. We'll certainly do that.
Well, you said this isn't the game our quiz tomorrow, right?
You're just balancing tomorrow, but this will be in the future. Yes. Yes. I'm sorry, repeat that again. What about gag on water?
Can you gag on water?
Yes.
And then vomit?
Yes.
Can you vomit out of your nose?
Yes.
No, you can't. You just did it.
I don't know if it came out.
I watched it.
And then
It's not in the water. Holding it like this. It's not in the water.
All right.
water, and then there was just like this shred.
Hydrogen chloride. What's the symbol for hydrogen? What's the symbol for the chloride ion? Okay. What is the symbol for zinc? Okay. So, this is telling you in a single replacement reaction. Even if you didn't see this, how could you tell that this is a single replacement reaction? No.
Because it's 1 plus 1 equals 11.
Adding 1.
Is it diatomic?
What do you see? Is zinc by itself? Yes, it is. Okay. That's why it's a single replacement. Okay. So, is this compound balanced out?
No, yeah.
Okay. What's the charge of chlorine?
7. -1.
What's the charge of hydrogen?
+1.
Those add up to 0, correct? So when we say single replacement, what did your paper say? You have a lone element that replaces another element in a compound, but on that side. Okay? So can two positive charges bond together? No, they cannot. So what is the only thing zinc can replace?
Chlorine. Hydrogen.
Hydrogen.
It has to go with it.
Okay? So you correctly said zinc in this reaction will replace that hydrogen. Okay?
Don't you need 2 chlorides to balance?
Well, we're not done yet. So when this replaces that hydrogen, that means this is all by itself now, but it's on this side. We'll come back to the zinc chloride.
Diatomic.
Hydrogen's diatomic. So what does that mean?
You need 2.
You need 2 of them, because if you just do this only and you leave it like this, doesn't matter what you do beyond that, everything's going to be wrong. Why is that? Because you got to remember, some of you pointed that out. Hydrogen's a gas, so that means wait a few moments. Okay? So, what else besides gases are diatomic? No. What is column 7 called? The halogens. Okay. So, what is the best way to approach balancing this? Give me some elements. We've got what, and what?
Hydrogen, zinc, and chlorine.
Okay, hydrogen's left. Well, then why don't you move up a little closer then? Okay,
Right up there.
hydrogen's left. Hydrogen's right. Zinc's left. Zinc's right. Chloride's left. Chloride's right. Okay? So in front of each one of these elements or compounds, there's a coefficient of 1 right now. Okay? So where are we going to start to balance this? It's all in the same spot.
I'll just put a 2 up front and all that, and then you're done.
Okay? That gets distributed through the entire compound now. What's 2 times 1?
2.
What is 2 times 1?
2. 2, 1, 1, 1.
Okay? So that means we've got 2, 1, 1, 1. Okay. Okay. What is hydrogen sulfate? What's H? What is sulfate? Okay. Now, what is the charge of sulfate? What's the charge of hydrogen? That doesn't add up to 0. Need 2 hydrogens. Okay. What is the symbol for cobalt? Okay. We don't need to write that down because it's telling you that this has a +3 charge. Okay, so from our prior example, how do we know this is a single replacement reaction? We have a lone element right here. Okay, so if this forms a +3 charge, which it does, okay, what does the cobalt replace in this single reaction but on that side? Okay, so the charges will not change. So anyway, do any of these subscripts go over to the right side? It does. Why are you right when you say that? No. Because this is part of the formula. Okay? So that 4 has to come over here. Okay? What about this hydrogen? Hold on. Hold on.
Add an H2.
Okay.
Do plus H2.
Does this subscript go over there? Okay. Why is that? It's diatomic. Okay. Charges do not change. That doesn't add up to 0.
You need 3 sulfates and 2 cobalt.
Okay. Who does not understand why you're putting 2 and 3? If you don't know, now's your opportunity. How did you come? You're right. How did you come up with that?
It's 2
So
times.
charges add up. 2 times 3 is 6 and 2 times. Well, what does it take?
So what does that have in common? 6 must be the least common what?
Multiple.
Right. So 6 divided by 2 gives you 3. 6 divided by 3 gives you... Okay. So, give me some elements, please. Hydrogen. What else besides hydrogen and sulfate? Anything else? Hydrogen's left.
1, 2,
Hydrogen's right.
2,
Sulfate's left. Sulfate's right. Cobalt's left. Cobalt's right. Okay?
I wish I could read this.
Yes. Just wait a moment. Okay. So, where do you want to start with balancing this? Just do this?
Yeah.
Okay.
Put a 3 in front of you. Put a 3 in.
Right here? Okay, that gets distributed through the entire compound.
So that way your sulfates are made.
What's 3 times 2?
6. Need a 3 in front.
What is 3 times 1?
3. Put a
Okay.
3 on your last hydrogen.
3 times 2? 3, 2, 1, 3. Okay? All right. Then we'll just get this set up. Then it'll be your opportunity to finish that. Now, do any of these subscripts go over there for sure? This does. Why is that? It's part of the formula. Why does this? It's part of the formula there too. Okay, so in a double replacement, the positive charge of one compound bonds to the negative charge of another one, but on that side. So, what is the charge of chloride? Negative 1 times 3 gives you negative 3. Okay, so that must mean this iron has to have a charge of plus what? 2? Does that add up to 0?
No.
Well, who said 2?
Chris?
Okay. If it's not plus 2, it must be what? Okay. What's the charge of sulfate?
-2.
What's the charge of ammonium?
+1.
Now, what is ammonium going to bond to but on that side?
Chloride.
You split apart the ion, so you said NH4. The 4 is part of the formula. What else then? Why is it Cl? You're right.
Because it's a negative charge.
Because it has to bond to a negative charge. Okay? What is the iron going to bond to but on that side?
Sulfate.
Okay? Okay?
You need 2 iron.
Okay, that does not add up to 0 like this does.
2 iron and 3 sulfate.
We're not doing oxidation and reduction reactions, so yes. Okay? So this does not add up to 0. What's the least common multiple?
6.
What's 6 divided by 2? What's 6 divided by 3? All right. So that's all I've got. You can balance this out. I'll hand out your paper, which will be due on Thursday. Tomorrow, problem evaluation on balancing. Balancing only. You don't have to classify them.
Can I go to the bathroom now?
Yes, you may go.
Alright.
All right, we'll catch up to you next time.